Hey guys, welcome to the Tech Granth. Today we'll solve the problem of removing nth node from the end of the list. So we are given a linked list and we have to remove nth node from the end of the list. Do like and share the video, subscribe to the channel to get further updates. And I have also started a tutorial on data structure for beginners. So if you're interested, you can have a look at that. So here we are given a linked list like this and a number. So this n number, so we need to remove the nth node from last. So if n is equals to 2, so we need to remove the second node from the end, which will be this node. So the output will be 1 2 3 4 3 5. So let us see how we can solve this problem. And it has been given that n will always be a valid number and you could do this in one pass. Could you do this in one pass? That is a follow-up thing. So yes, we will do it in one pass only, but let me explain how we can approach this problem. So if n is equals to 2, one way will be to find the number of nodes in this linked list. So basically get the length of the linked list. So if we get the length of the linked list, here L is equals to 5. So we can say that 5 minus 2 equal to 3. So after third node, whatever node comes, we have to remove. So remove node after this node. So that is what it will mean. So for removing that node, what we can do is the third node dot next is equals to, so third dot next, currently third dot next is 4 and 4 dot next is equals to 5. So to remove the fourth node, what or the node with value 4, what we can do is we can say 3 dot next is equals to 4 dot next. So the pointer will go from 3 to 5 directly and it will skip 4. So that is how we will remove the fourth node. But to get the length of the linked list, we have to traverse the linked list once throughout. So that is what they were asking here, that can this be done in one pass. So to do it in one pass, we can think in terms of some of the problems that you might have encountered before, where you have to remove, like if there is a circle in a linked list, then remove that circle kind of thing. Or in case you have two linked lists intersecting each other, so then in that particular case, how you will solve those problems. So when we solve problem based on linked list, generally that two pointer concept comes, where you have a slow pointer and a fast pointer. So we'll try to see if we can do the same thing here. So if n is equals to 2 and I have my slope, suppose I have my slope pointer here, and if I increment my fast pointer 2 steps ahead, if I can make my fast pointer here first, and after this if I keep on incrementing both the pointer once, so when fast will reach the fifth point, the slow will reach its correct position, right? So we'll try to implement this, where we will first move the fast pointer to n plus 1 position and n plus 1th position, and then we will move both and slow and fast pointer together, so that when fast ends, slow will be at the point or at the node where we have to remove the next node from there. Okay, so let us try to implement that. And we need to consider one more scenario, which will be like edge case. So what if we have to remove the first node itself? So to handle that, what we will do is we will create a dummy node first. We'll say that temp node is equals to new list node of value say 0, and temp dot next is equals to head. So anything after this temp node, it will be the head of list node, whatever we are getting the input from. Now we will create our slow pointer. We'll make it as temp. We will create a fast pointer that will also be at temp first. We need to move the fast pointer first till n is greater than equal to 0. So while this is greater than equal to 0, fast is equals to fast dot next. and we'll decrement n. So this will make sure that our fast pointer has gone n plus 1th step. So once this is done, then we can simply say that while fast is not equal to null, so this is basically looping through the remaining of the linked list till it reaches the endpoint. So slow will reach its corresponding point. So when till fast is not equal to null, so fast is equals to fast dot next, and slow is also equal to slow dot next. So once we have the slow and fast pointer, and when we come out of the loop, it means that the fast pointer has already reached its end point, and slow pointer has also reached the node after which the node means it has reached a node before the node which we have to remove. So in this case, the slow pointer has reached 3 now. So what we can say now is slow dot next. This should be equal to the node after the next node. So it will be slow dot next. Okay, so this way it will, if it is at 3, it will skip 4 and it will point to 5. And once we have this, then we can simply say return temp dot next. Why we will say temp dot next? Because the first node of temp is the dummy node that we have created. So if it follows all these and all the slow pointer and all these are like just a reference to this temp itself, so it will inline solve our problem and it will create the list. So let us run the code for a test. Seems okay, it is accepted. We don't have any other example, so I will submit the solution and it is accepted. So that is how just by using one pass we are able to solve the problem. Now the thing to keep in mind is whenever a question related to linked list is there, and if the interviewer is asking you to use one pass or reduce the time complexity or space complexity kind of thing, so you should always think in terms of a fast and slow pointer. In case of linked list, it will always come handy to you. It's like a similar approach when we are traversing a string and we use two pointers. So it is like that left hand thumb rule for solving a linked list problem. So yeah, try to solve as many problem as you encounter and let me know if you're stuck somewhere. That is it for this video. See you in the next one. Take care. Bye.